Welcome to my second video on chi-square testing. In this example, we're going to use contingency tables to determine if somebody's gender has any influence on the political party they support. So what we did was ask a group of 100 males and females if they were Republican, Democrat, or another political party. So the first thing I like to do is calculate the total number in each row and each column. So let's calculate the total number in the row of males. How many males do we have? Well, we have 26 male Republicans, we have 13 male Democrats, and we have 5 other males. So if we add all these numbers together, 26 plus 13 is 39. 39 plus 5 is equal to 44. So we have 44 total males. So I'm just going to write total in this row over here. So we have 44 total males. So now let's do the same thing for females. How many females do we have? Well, we have 20 female Republicans, we have 29 female Democrats, and we have 7 other females. And if we add all these together, 20 plus 29 is 49. 49 plus 7 is equal to 56. So we have 56 total females. So if we add the males and the females together, 44 plus 56 is equal to 100. We have 100 total people that we observed in the study. So now let's do the same exact thing for all of the columns. Let's start with the column with the Republicans. How many Republicans do we have? Well, we have 26 male Republicans. We have 20 female Republicans. 26 plus 20 is equal to 46. We have 46 total Republicans. Now if we move on to the column of Democrats, we have 13 male Democrats, we have 29 female Democrats. 13 plus 29 is equal to 42. We have 42 total Democrats. And for all of the others, we have 5 male others and we have 7 female others. 5 plus 7 is equal to 12. We have 12 people who are not Republican or Democrat. And if we add all of these totals in the columns, we have 46 plus 42 plus 12, which is also equal to 100. So that confirms that we have 100 people total in this study. So what we're going to do is use all this information to fill in our expected table. This table is all of the values that we expect. So let's start with our male Republicans. How many male Republicans do we expect? The expected number of male Republicans, and the formula that we're going to use for male Republicans is the total number of males multiplied by the total number of Republicans, all divided by the grand total, the total number of people in the study. So if we plug everything into this formula, we know that we have 44 total males. So we have 44 males multiplied by the total number of Republicans, and we know that we have 46 total Republicans. So this is multiplied by 46, all divided by the grand total. We have 100 people total in the study, so this is divided by 100. And if you plug this into a calculator, 44 times 46 divided by 100 is equal to 20.24. So the expected number of male Republicans is equal to 20.24. So now let's do the same exact thing for the female Republicans. How many female Republicans do we expect? The expected number of female Republicans, and that's equal to the total number of females multiplied by the total number of Republicans, all divided by the grand total, the total number of people in the group. So if we plug everything into this formula, we have the total number of females, which is equal to 56. So we have 56 females multiplied by the number of Republicans. We know that we have 46 Republicans, so this is multiplied times 46, all divided by the grand total, which we know is equal to 100. And if we plug this into our calculator, 56 times 46 all divided by 100 is equal to 25.76. This is the expected number of female Republicans. So we have 25.76 as our expected number of female Republicans. So I think you get the idea by now. To get the expected value of male Democrats, you would just multiply the total number of males times the total number of Democrats, all divided by the grand total. So just to save a little bit of time, I'm just going to fill in the rest of the expected values and not do all of the calculations. So as you can see, now we have filled in the rest of the table with our expected values. So now that we have our expected values and now that we have our observed values, now we can perform our chi-square test to see if the observed values fit the expected values good. And the same steps that you use for a hypothesis test, we're going to use for a chi-square test. So here I wrote down for you all of the steps for performing a hypothesis test or a chi-square test. And step number 1 says to state the null and the alternative hypothesis. So let's go back to our example and let's start with our null hypothesis. The null hypothesis is written with h sub 0 or h naught. So let's state our null hypothesis. The null hypothesis is always what you currently believe to be true. So you have to believe that the rows are independent upon the columns, or in other words, the gender is completely independent upon the political party you support. So this is our null hypothesis. The political party is independent upon gender. The gender has no influence in which political party you support. So now let's state our alternative hypothesis. The alternative hypothesis is always written with h sub 1 or h sub a. It doesn't matter which one you use. And the alternative hypothesis is always the opposite of the null hypothesis. So since the null hypothesis states the political party is independent upon gender, the alternative hypothesis must be the political party is dependent upon gender. So the alternative hypothesis states the political party is dependent upon gender, which means that your gender does influence which political party you support. So now we have stated our null and alternative hypothesis, so we are ready to move on to step number 2. So step number 2 says to choose your level of significance, which is written with the Greek letter alpha. And the level of significance is nothing more than the area in the tail. So let's go back to our example, and I'll show you what I mean by this by drawing a picture of a curve with a chi-square distribution. So here is a picture of a curve with a chi-square distribution. Sometimes it looks a little bit different depending upon your degrees of freedom, but for the purpose of this video, this curve will do just fine. And like I said before, the level of significance is the area in the tail, and I colored in the area in the tail in red. And the level of significance, if it's not given to you, you can choose your level of significance, and it's usually a value between 0.01 and 0.05. The lower the value, the more significant your results. So I'm going to pick a level of significance, the Greek letter alpha, of 0.05. So this value of 0.05 is the area in the tail. So we know that this area that I colored in red is equal to 0.05. So why is this area in the tail so important? It's because this is called our rejection region. Once again, this area in red, the tail, is our rejection region. And the reason why this rejection region is so important is because it allows us to make a conclusion at the end of our test. And we're going to perform a test, and we're going to get a value. And if this value happens to fall in the rejection region, that means we can reject the null hypothesis, which states that the political party is independent upon gender. And we can accept the alternative, which states the political party is dependent upon the gender. So this rejection region allows us to make a conclusion at the end of our test. So now that we've stated our level of significance, we are ready to move on to step number 3. Now step number 3 says to find the critical value. Now the critical value is nothing more than the point that separates the tail from the rest of the curve. So let's go back to our example. This point which separates the tail from the rest of the curve is our critical value. And this critical value is going to be a chi-square value since we're using a chi-square test. So how do we find this critical value? Well, we need to use a chi-square table. And one thing to keep in mind before we look at our chi-square table is the area in the tail. We're going to use this area of 0.05, and it's going to help us to find our critical value. So let's go back and look at a chi-square table. And two things that you need to know are the area in the tail, which is 0.05, and your degrees of freedom. Your degrees of freedom is always equal to the number of rows minus 1 times the number of columns minus 1. So we had 2 rows, male and female. So we had 2 rows, and we have to subtract that by 1. And we had 3 columns, Republicans, Democrats, and others. So we had 3 columns, and we've got to subtract that by 1. And if we multiply these together, 2 minus 1 is equal to 1, multiplied times 3 minus 1, which is equal to 2. So our degrees of freedom is equal to 1 times 2, which is equal to 2. So we have our degrees of freedom of 2. So we're going to use this row in our table with degrees of freedom 2. And we know that our area in the tail is equal to 0.05. And the subscripts below the chi-squared value is the area in the tail. So this subscript of 0.05 means the area in the tail is 0.05. Our degrees of freedom is 2. And these two rows intersect at the critical value of 5.991. This is our critical value, 5.991. So let's go back to our example. And we know that our critical value is equal to 5.991. So now we are ready to move on to step number 4. So step number 4 says to find the test statistic. Now, since we're using a chi-squared test, this is going to be a chi-squared value. So let's go back to our example. And to find this chi-squared value, we just need to use a formula. So the symbol for chi-squared just looks like an x with a squared symbol on top. And the formula for chi-squared is equal to the sum of all of the observed values minus the expected values squared. And this is all divided by the expected value. So I think this is going to make a lot more sense once we just plug everything into it. So let's get started right away. We'll start with the male Republicans. We observe that there were 26 male Republicans, and the expected value of male Republicans was 20.24. So we'll use these two values to plug into our formula. So our chi-squared value is equal to the observed value, which was equal to 26, minus the expected value, which was equal to 20.24. We've got to square this, and this is all divided by the expected value, which is also 20.24. So now we need to add this and do the same exact thing for the rest of the values in our table. So now let's do the female Republicans. Now we'll do the female Republicans. Well, we observe that there were 20 female Republicans, and the expected value was 25.76. So we're going to use these two values and plug them into our formula. So we observed that there was 20 female Republicans, and we need to subtract it from the expected value, which was 25.76. This is all being squared, and we need to divide it by the expected value, which is also 25.76. So I think you get the idea by now. You need to take the observed value, subtract it from the expected value, square it, and this is all being divided by the expected value. So just to save a little bit of time, I'm going to do the remaining 4 values all at once. So here we finished off the rest of the table. This is our value for male Democrats. This is our value for female Democrats. This is our value for male others. And this is our value for female others. And if we add all of these together and plug it into a calculator, we get a value of 5.86. This is our test statistic. So how do we use this value of 5.86, our test statistic? How do we use this value and draw our conclusion? Because this is our last step. We need to draw a conclusion to our problem. So what we're going to do is plot this on our curve. So let's go back to our curve and plot our test statistic. Well, we know our value of 5.86 is certainly less than 5.991, our critical value. So since it's less than 5.991, then we know that it has to be to the left of the critical value. So I'm going to just plot and estimate the test statistic to be somewhere to the left of the critical value. So this is our test statistic of 5.86. And notice how this value of 5.86 does not fall in the rejection region. It's not in our tail in red, which means we cannot reject the null hypothesis. We fail to reject the null hypothesis. Or in other words, we have to accept the null hypothesis. We have to accept that the political party is independent upon gender. Your gender does not have any influence on your political preference. So I hope this video gave you a better idea on how to perform a chi-square test. I do have another chi-square example which is different. It involves rolling a dice. The link for this video is in the top left corner. I also provided the links for all of my hypothesis testing videos, so check those out if you want. Thank you so much for watching. Don't forget to subscribe if you want to see all of my new videos, and I will see you in my next one.